Hi, this is Jay McClellan, and this is part 2 of my project to build a T-slotted faceplate for my metal lathe and for my 4th axis assembly. In the part 1 video, I made the basic faceplate, starting from a rough block of steel and doing the lathe work to turn it into a round faceplate with finished surfaces. And in this video, I'm going to use the milling machine to cut the T-slots. Here's my setup for milling the T-slots in the front of the faceplate. I have a stop block clamped down to the table here and here, and then I have these 3 clamps loose at the moment so that the faceplate can rotate a little bit, and I'll align it so that the 2 holes, this pair of holes, is in line with the axis of the mill. I have an angle block already aligned to the mill's axis, and I'm just putting a square on it and lining up the holes visually. The angle of these slots is not critical at all. That's aligned acceptably. I'm going to clamp it down really firmly, and then I'll align the mill to the center of the faceplate and start cutting the grooves. So I have everything aligned and solidly clamped down, and it's time to make the initial slot cut. And I'm using a 3/8 inch roughing mill. My total depth, in order to match the slots on my milling machine, needs to be about 0.6 inches, 600 thousandths. And I'm going to cut about half of that in this pass. So it's a fairly heavy cut, but not crazy heavy. I started out the cut applying lubrication with a brush, but I could see the chips were getting kind of dark, indicating heat buildup. So at this point I switched to a pump oiler in order to apply oil more rapidly to get a better cooling effect. Okay, I plunged down to 590 thousandths, a little short of my final depth, so I can do a cleanup pass, and I'll go back the other way. Well, from the top that looks like it went pretty well, but actually there's a problem. The end mill cut pretty well, but it slipped in the collet, and because of the helix angle, the helix is trying to pull the end mill downward as it's cutting, and it did slip downward about 1/10 of an inch, about 100 thou. So that made my groove about 100 thou deeper than I really wanted it to be. It's still going to work. It hasn't ruined the piece, but it's definitely a lot thinner on the bottom than I intended. Fortunately, for the way I'm going to use the faceplate, it'll be okay because it's going to get bolted down to a backplate that will reinforce it. I removed the end mill and collet from the mill and cleaned everything really well, and then put it back in and tightened it really well. And I reset my depth to be the depth that I intended to make the slot, and you can see how far the end mill dropped during my previous cut. It's definitely bad. I'm disappointed with that, but it'll still be usable, and so I'm going to make the rest of the cuts at the desired depth, and this slot will just be a little bit strangely shaped, and we'll let that be a reminder to me to be careful of this sort of thing in the future. So I've moved the y-axis by 50 thousandths, and I'm going to cut into the side, 50 thousandths on this side, 50 thou on the other side, and that'll bring the total slot width up to the same width as the slots on my milling machine table, which is about 485 thou. Well, that looks pretty good, and this is one of my T-nuts for my clamping kit, and it fits nicely in the slot, just a nice sliding fit, but not sloppy. So I'm satisfied with that width. Now it's time to cut the T-slot, and my slot cutter is a little bit smaller than the size of the slot I want, so I'll need to make 2 passes on each side to bring the slot up to the desired dimensions. I cut down one side and back up the other side, so I've got the slot cut on both sides down to the desired depth of the slot, 600 thou below the top surface of the faceplate, which is where I wanted my roughing mill to cut, but it did not. And to make the slot high enough, I need to raise up by 50 thou now. All right, so I've come up 50 thou, and we'll repeat the process. I finished the slot cuts on the side and checked the fit with a T-nut, and it fits nicely. So this slot is done, and I just need to repeat the process for the other 2. I rotated the part by 120 degrees for the next slot, and I refit the roughing mill to start the roughing pass, and this time I put the roughing mill in the collet so that the top of this flute was right at the bottom of the collet. And after one pass, cutting about half the slot depth, I can see that in fact it did slip again. That's even though I made it quite tight. I didn't take it all out and clean it again, and I should have. So fortunately this was only the first pass and not full depth, but it did slip as I was cutting. I'm going to remove this, clean it out really well, tighten it really well, and I'll just have to do that every time I fit this mill to a collet. It just puts so much torque on that the collet can't hold it unless it's really clean. Well, once again, I removed the collet and the end mill, cleaned them very well, put them back in and tightened them very well. So I'm ready to make the second pass on my second groove, and I'm not going to crank it down to full depth this time. I'll stop about 50 or 60 thousandths short. Well, my slot cutter did, I think, a pretty good job on the first T-slot, and it did an okay job on the first half or the first cut through the second T-slot, but as I'm coming around the other side, it's just not cutting well at all. I think it's getting dull. Well, my high-speed steel slot cutter made it about halfway through the project. I was able to cut about 1.5 of the T-slots before it became really just too dull to continue. And I'm not pushing it real hard, and I've been giving it plenty of lubrication, so I don't know if it's just not up to the task, if it's this steel is especially hard. I don't know exactly what alloy this is because I got it, as secondhand metal, so it's hard to say. It doesn't seem particularly hard when I'm starting to cut, so I don't think that's really the problem. But at any rate, it's clear that the slot cutter that I have isn't going to work, so I've upgraded to this carbide tipped slot cutter, and I'm going to use that to cut the remaining T-slots. This is actually a key seat cutter, and it's made for cutting a key seat such as along a shaft, and so it doesn't have a real lot of clearance here in the neck because it wasn't really intended for T-slot cutting. I think it's going to work fine, except I need to reduce this neck area because it won't quite fit into where it needs to fit. So I just need to remove a little bit of material from the shank right in here in order to have clearance for cutting the T-slot with it. I have the tool mounted in a collet on my metal lathe, and I'm going to use a carbide tipped cutter to remove just a little bit of material to reduce the shank size right in here. So here's my modified cutter. I removed just enough material on the shank to clear for the cut that I'm going to make. I didn't want to remove any more than I had to because it does reduce the rigidity of the tool. But I think it's going to work fine. It's still got quite a lot of meat to it, and now it will just fit down into the slot. The other thing I did to this tool is I ground a flat on the shank so that I can use it with an end mill holder instead of a collet. And I think that's going to work out a lot better. After the trouble I had with the roughing end mill, in particular slipping in the 1/2-inch collet that I was using, I decided to upgrade to a set of end mill holders. So this is an R8 end mill holder, and you can see it has a big set screw that bears against the flat that I made on the shank of this mill. So this is now my T-slot cutter that I modified, so I'm ready to resume cutting the T-slots with carbide cutters instead of high-speed steel, and hopefully these will hold up better. Well, my new carbide slot cutter cut very well, very smoothly, didn't feel like it was bogging down at all. And as long as I don't push it hard, I think it's going to stay sharp for a long time. And I got a nice sliding fit with my T-nuts. So this T-slot is done. I have 2 T-slots finished, and it's time to cut the final one. I've rotated the part again and lined it up with my square against the 2 mounting holes. So that should be close enough for my purposes. And I've switched to a smaller end mill for the simple reason that my larger one was getting dull. And this one hasn't been used much. This is a 5/16 inch end mill, so a little bit smaller than the 3/8 I was using, but it should work fine. If my slots are a little bit wider, I have a 1/2-inch carbide roughing mill, but that would be too wide for these slots. So this is a high-speed steel mill, 5/16, and it's in an end mill holder this time. So I'm pretty confident it's not going to be moving moving down like it did when I was cutting with the collet, and hopefully this slot will go more smoothly. The total depth of the slot is going to be 630 thousandths, and I'm cutting about half of that in the first pass. So I'm going to try to cut it in 2 passes, and we'll see how that goes. I'm going to run it probably about 600 RPM, which is medium slow for an end mill this size. As before, I'll be using a lot of oil with my pump oiler on this to try to keep it cool. That cut really well, and I think I could probably cut full depth. The end mill certainly would take the force of cutting full depth, and I think the mill would be okay, but that would also produce about twice as much heat. And it's warm, but not terribly warm. I think I've got enough cooling, so I'm just going to keep going with it at half depth. So that looks pretty good. Now I'll crank it down to almost the final depth and do the very final depth with the slot cutter. Well, that cut quite well, I think, and it looks like I was able to flood it with enough oil to keep the bit reasonably cool. This bit is a little bit smaller than the one I used before, so to get to the proper slot width I need to come out 75 thou, and that should be wide enough for my T-nut plus just a little bit for a nice sliding fit. And I'm going to cut, now that I'm not doing a plunge cut, but I'm cutting just on one side, I'll be doing a conventional non-climb cut. So I'm going to cut the full depth and just take off 75 thou as I go. So with the straight groove cut, it's now time to run the slot cutter down. So I've got it set to cut, the height here is to cut the top of the slot wing, run it down and back, and then I'll have to do it again, lowering it down a little bit, and that should wrap it up. Because this is carbide tipped cutter, I'm running it at a much higher RPM. So this is running at about 1280 RPM for this cutter, which translates to about 200 surface feet per minute cut speed, and that's just about on the bottom end, the low end for carbide cutter. So it should work fine. It's none too fast, but it should be fast enough to get a decent cut out of it. So far so good. Now we'll just drop down to the bottom depth and repeat the process. So I finished the passes of the slot cutter to cut the wings on the final slot, and I've got a nice smooth sliding fit with my T-nut. I cleaned up the faceplate and deburred the edges, and it's now done. Until just now I hadn't noticed how much it looks like a radiation symbol. That wasn't really intentional. But anyway, I was concerned that because one of the slots cut a lot deeper than I intended due to my slipping end mill, I was concerned that it might have relieved stresses unevenly in the steel and caused it to curl up like a potato chip. So I put it on this granite surface plate, and it sits, as far as I can tell, perfectly flat. Flipping it over, the other side also sits perfectly flat as far as I can tell. I could put measurement instruments on it to try to determine any curvature that's left, but honestly I'm not going to, because the way I intend to use this, it's more than perfectly flat enough for my purposes. So quite happy with that, happy with the way it turned out in general. Here you can see the T-slot profile, and this is how I intended it to come out, so that looks pretty good. Here's one side of the T-slot, the first T-slot that I cut, and you can see where my end mill slipped, and so it slipped down, got pulled down out of the collet, and it isn't too bad here. It cut a little bit deeper, not too bad, but this was the side where the end mill entered the cut, and by the time it got around to the other side, you could see how much more it had slipped. So that it moved that much farther down, just cutting one distance across the faceplate, and I'm really lucky that it stopped there and didn't move any farther and cut down through the part and into the table of the mill. So it's certainly overall thinner than I intended in that particular axis, but it's thick enough, and it'll be bolted to a fairly beefy backplate. So in practice it'll work okay. To mount the faceplate on the 4th axis assembly, first I make sure the mating surfaces are nice and clean, and then just set it on and lining up the bolt holes. It's a nice snug fit, so it's just right, just where I wanted it. So I just set it on and then put in the 3 bolts and tighten them down. And then once it's mounted, I can just slide in T-nuts to mount up to 6 T-nuts to secure any type of part that I need to secure. Well, that wraps it up. I have a faceplate. It's not perfect. It's got a little bit of interesting construction characteristics due to some of my slipping end mills, but in general it's very usable, and I look forward to using it in future projects. And I learned a few things. One thing I learned is that collets for holding end mills are okay, but not great, especially for roughing mills. Really, holding a roughing mill for any kind of heavy cut like I was trying to do is kind of marginal. And so from now on, now that I have upgraded to a set of end mill holders, I'll be using end mill holders for pretty much anything I can whenever possible, but certainly for roughing cuts, I think it's a better choice. I got on this, I think, a really nice looking surface finish, and it makes me wonder what kind of steel this actually is. You know, I bought it by the pound. It was 40 cents a pound, so it cost me $3. I can't complain too much for $3 in steel. But I have to wonder, it didn't seem really hard, but I wonder if it's some kind of tool steel that's not hardened, not in a hardened state, but still tougher than mild steel, because it really did seem to dull the cutters faster than I would have expected with just mild steel. This high-speed steel slot cutter really didn't hold up to the task. It's pretty dull. So it's going to be sitting in a drawer until I have put together a way to sharpen it. But it did okay, but I got about halfway through the project and it just wasn't going to cut anymore. So the other thing I learned is carbide is good. I like carbide, a lot of people do, but especially I think for cutting an unknown kind of steel like this, you know, a bit of a tougher cutter might have some advantages. I think as soon as I realized that the high-speed steel cutter was starting to get dull, that would have been a good time to switch to carbide, but I didn't have carbide at the moment, so it took a couple days to order a cutter, and modified this Woodruff key seat cutter to be a slot cutter, just with a little bit of modification on the shank. So that worked out pretty well. So on the whole, learned a few things. Ended up with a nice usable faceplate. So yeah, pretty good project, and look forward to actually making some projects using it. So Hope you enjoyed this. I did. Thanks for watching.